All right, now this one is doing what it should. See the video over there for further details. Let's get this other smaller little moving light together. See if it is easier to put together, fits just as well. I'm wondering which one I should carry on with, or maybe if somebody knows about another variant on this theme, maybe I should look at that one. Comments down below, etc. You know. Anyway, let me move this stuff out of the way and bring back in the rest of my supplies, and I'll get right at her. This smaller light, the uploader to Thingiverse calls it the Moving Ed. I like that. Just judging by the pictures, it looks a little bit rough. You see this gap here between the top and bottom sections. There's what the internals of the top looks like, just the servo, the LED, and a lens that I don't have, but we'll make do without that for now, until we see if this is the one that I want to make a bunch of or not. Interesting, in the files with it, there's also this road case, which is kind of cool, but I didn't bother printing it. Not at this time anyways. But what we're interested in is this yoke and the top and bottom of the light and the base. Now it says down here that you need to print two of the bodies, but you have to print one of them mirrored. So the top and bottom are exactly the same, just mirror images of each other. Right. There's a few other things here too. And actually, they've got a link to a GitHub, which has their entire project, so which has a few other bits and pieces in it as well, which are kind of neat. So I have the parts all printed, and yeah, I made the mistake of not mirroring it first of all, so I've got two of one half. But that's okay. If I screw up, then I've got another piece that I can play with. So it says that the servo that goes on the top needs to have the ears trimmed off it, and I guess that makes a certain amount of sense if you're going compact. So let's just do that. Not sure if this is the cleanest way to do it, or should I be using a Dremel or a knife or a saw or something? I don't know. Let's see if this works. Plastic's kind of soft and crunchy. It's not really... Ah, there we go. Okay, that did work. So I'll just carry on with this side, maybe not be quite as gentle. I don't know where that went, but it didn't go in my beer glass, so I don't really care. Right, does that fit in here now? Okay, so that fits in there. And then where is the other top half? It's a little tight, but I think... Can I trim that down a little bit? Yeah. I think I may have to do a little bit of trimming there. That might just be some elephant's foot on the print. Ow. Nope, didn't hurt myself. Good. Okay, after a little bit of fitting, that actually closes. Almost as good as it did in the picture. Cool. So then that goes into the yoke. So I think what I have to do is put that in there first and sort of set that up that way. Then stuff that in to that hole there, and oh, that's not actually going to fit. Okay. I have to carve that hole just slightly bigger, but not too much bigger, because the grip on this thing comes from the little knurl around there, so it's got to be sort of a press fit, but not a complete jam. It's kind of a bit of a balancing act. Okay. After carving it just a little bit too much, it's oversized. Damn it. I guess I'm going to have to resort to a little bit of hot glue in there and then back it up with a screw. Because I do want a little bit of space in there. I don't want that jammed right tight. Well, no, that's deep enough. Okay, that's going to work. So just put the screw in there, and well, maybe the clamping pressure will be enough. Yeah, there's a little gap in there, so it's not jammed that against that body. So I guess that'll work. How to get that on there with that in the way. Order of operations is quite important, it seems. I'll take that off. So that has to come in like that. And this goes in like that. And then I guess this goes in like that. Sure. Okay. We're getting there. But now I have to, with all that, I have to fit this out through the hollow spot in the arm here. Because the same as this one here, the wires go down through a hollow inside the arm and come out the bottom there. So you can see in that side there is a hollow. I can run the wires up. I'm going to use this, which is just a piece of ribbon cable for my LED wire, and I'm just going to use the same little NeoPixel WS2812 as I used the last time. But I don't think I'm going to be able to do it even with the crimped pins on. I think I'm going to have to just thread the wire through and then solder it later. I'll cut that back a little bit so that I can just solder that together and heat shrink it. Push that down through there and this down through there. That is tight. That is all I can get down there, I think. There it comes out the bottom. Cool. And that is going to come out the bottom and go through that widened thing there. I'm going to need another serval. There's one that doesn't have a horn on it. That will go in there. I may have to trim the ears off it too. But regardless, it comes up the center there. And then this will sit down onto that. Yeah, I think I am going to have to trim. That one seems like it'll fit, but I'm going to have to trim this one down, I think, to make it fit in there. Now, the LED that this thing was designed for is a specific package of Adafruit NeoPixel, which I don't have. The closest that I've got is these little star ones, but the one that these little notches in here fit. These notches here is assuming, I think, an 8-sided board, and these little 6-sided boards don't quite fit in there. Besides, they don't have pixel addressable LEDs in this form factor anyway. So remember from the last video, I printed out a bunch of random millimeter thick circles. So I think one of them, if I did it right, yeah, the 20 millimeter circle fits in that little slot fairly well. So I'll just cut a little gouge out of the side of it so that I can get my wire past it. I'm not going to nip it this time. That one I nipped and cracked it right in the middle. So I'm just going to use my soldering iron to make a little notch in it. I think that's probably going to work well enough. This doesn't have to be precision engineering. Alright, let's try and fit this together if possible. So I need a bottom piece here. Oh wow. This is going to be interesting. Hadn't tried to do this with the wires in there yet. But that has to come out here. And that has to come... oh wow. So that needs to go in that way. So with that vaguely in place, and this has to slip in that way and clamp down that way. Hey, I think I got it. Haha! I think that's going to work. There's no mechanism to clamp this thing together. Oh. And the screws work itself loose. Right. spin that around that way. And tighten them back up again. We'll have to see. Anyway, let's get back to this base for a second. I think I do have to knock that tab off there so this thing will fit. Ow. Into there. Go over a little bit that way. So that sits a little bit proud at the top. And this guy, poke the wires through, I guess. Again, I'm going to have to take this all apart after I test fit it, just to fit it back together again. I hope it's not too much of a pain, but we'll cross that bridge when we get to it. So then that goes onto there. Oh. That is loose and rattly. I think that needs to be pushed through a little bit further. I think that, yeah, that needs to be sitting a bit more proud. So, okay, I got it. It took some carving, and I even drilled a hole in there and put a screw in, and it's so tight that the label peeled as I was jamming it in there. So I don't think it's going anywhere. But now it's standing proud at the top, and when I put this down on top, I'm not fouling on the body here. But I am fouling on this. That's too deep. But I think I'm just going to use hot glue in there anyway. However, as I discovered on the other one, I have to put that screw in before I assemble this piece up here. So I'm going to take it all apart again and deal with that. And got my hot glue gun warming up again so that hopefully it's ready for when this is ready for it. I don't know what else I'm going to have to deal with on this thing. I'll burn that bridge when I get to it. How does this come apart? Oh yeah, this side has to come out first. Right. Wow, everything is so freaking tight. I mean, good tolerances, person who modeled this thing, but wow, the order of operations of installation is so critical. Here goes nothing. Oh, that hole's full of glue. Either I've glued the servo on, or it's going to work. I'm just going to hold that separated so that there's a chance that it might actually work. I don't know, I might have to reprint this thing so that with a, but the hole didn't fit, so I don't know. Anyways, I'm going to let that glue dry there, and I'll reassemble the top just like you saw before. And then I guess once that glue is dried, we'll test it. Yes, I can re-splice these wires back together too, so that I've got a convenient connector on the end of them. That would be nice. Now then, I soldered those pins onto the LED in the order that they are here. So 5 volts, then data, and then ground. And I marked the ground wire with a bit of black Sharpie, which has mostly rubbed off in my screwing around, but I think, yeah, that's this one here. Ground is on one side, then 5 volts in the middle, then signal on the other end. So this is ground, and it'll go on one side. Get in there. Click. Then I need 5 volts, which is that one. So these wires have to cross based on how I soldered them in. And then the data pin goes on the outside. I just have to remember when I'm plugging it in what order they go in. So now I guess the only thing to do is to hook it up to the board and try it out. I'm just going to use exactly the same board and connections as I was using to drive that one. Same software and everything. So we will just see what happens. Place your bets. Okay, there we go. So we're changing colors and that's working. It's just, yeah, that's jammed on the bottom there. I knew it would be. But it's trying to rotate, it's just mechanically kind of jammed down there because of that glue that I did. Okay, let me see if I can loosen it up a little bit without having to take this whole thing apart again, because that would be annoying. It's trying to go, but it's just not doing it. But I'm looking down inside here, and I'm not seeing the gears inside the servo turning. So I'm wondering if this servo was maybe bad before I glued it, because it is occasionally running. I had wanted to avoid taking this thing apart, but I don't think I can avoid it. Annoyingly. Is that enough to maybe get at that screw, just taking it half apart? Well, yeah, I think I can. Okay, so that's out. Now then. Yeah, I'm not seeing that bottom servo turning. Yeah, I think that servo is a bad servo. Okay. Well, regardless, I'm not going to take it back completely apart. I am going to stop this guy kind of mid-stroke to put the top part back together. So at least that works. And I think I know enough about this design now to confidently say that it's not bad. It's got some tolerance issues. It is a bit of a work in progress according to the guy who made it. But it does go, and complaints about it, there's no real method for clamping that top together, although these two sides sort of hold it, which is kind of cool. I dig the size of it. It goes well, I think, with this follow spot here. It's pretty similar size or scale, so that's cool. I don't like how the servos interface with the pieces that they mate with, both down there and up here. This one has cutouts in it, molded into it, so that you can put the actual servo horns, and they have the proper knurling and everything. So I think that is a more positive way of connecting them. But the hugeness of these, it's cool, but it doesn't really fit with the scale that I'm going with. I mean, I don't know. Somewhere in between the two of them might be the Goldilocks zone. Although I don't have the correct LED that this one calls for, although it's very similar. I don't have the lens. But this is bright enough for something that size, I think. It can cast a little bit of light onto you. So that's nifty. But yeah, mechanically, I think that one wins. But scale, size, this one wins. I don't know if I want to go to the challenge, difficulty, effort of CADing up something like this myself. Do you know of another one that I didn't find that is the same kind of idea? A replica moving light that actually moves. So presumably we'll either use these little servos, these little 9-gram servos, or I suppose one that uses the stepper motors that come in Arduino kits, because I think that's the smallest practical stepper motor. Hang on, let me just pull up my box of stepper motors. Yeah, these are the ones that come in a lot of Arduino kits. I think they would work not too bad with this large guy. They would definitely fit in there, although you wouldn't direct drive them onto there. You'd gear them or belt drive them or something like that. So that might not be super practical. there are other smaller stepper motors that you can get, like these ones that I've salvaged out of things. So maybe something like that could do the job. I don't know, but that would add mechanical complexity because, like I said, you'd want to be able to do multiple rotations on the stepper motor to make 90 or 180 degrees on the light. So you'd need belts and gears and stuff. Maybe that's not such a good idea. Anyway, if you have any ideas or suggestions, please drop them in the comments down below. Other than that, thanks for watching. There will be a link to the build of this one and a link to both of the Thingiverse pages in case you want to build either of these yourself, or see if you can remix it or something like that if you're skilled at CAD. Because no doubt pretty much all of you are more skilled at CAD than I am. Anyway, that's all I got for tonight. Thanks for watching. I'll talk to you later.